Some comets don't orbit the sun politely, they aim straight for it, and some of them never come back out. One family of comets gets so close its ice starts boiling away before it even reaches the nearest point to the sun. Every comet you've ever seen streak across the sky survived a version of that dive. Tonight we find out exactly which ones don't. Comets aren't one thing, they're a whole family tree, and we're climbing it, from the tame regulars to the ones the sun eats alive. First stop, the tame end of the family. Short-period comets, the ones that swing back on schedules we can actually set a calendar to. They come from the Kuiper Belt, a flat disk of icy leftovers past Neptune that never clumped together into a planet. Astronomers call the nucleus underneath it all a dirty snowball, ice, dust, and rock loosely packed, like a snowball nobody ever compacted. That nucleus is often just a few kilometers wide, smaller than a city, yet close to the sun it can grow a glowing head bigger than a planet. That's not a metaphor. A comet's atmosphere really can outsize the planet it's passing. Jupiter has spent billions of years working as the neighborhood's gravity cop, nudging loose ice sunward or flinging it out entirely. That job even earned Jupiter its own comet subgroup, Jupiter family comets, corralled into short, tight orbits by its gravity alone. Halley's Comet is the most famous of the short-period bunch, swinging by roughly every 76 years like clockwork. That wait means most people alive today get exactly one look. Halley isn't due back until 2061. Short-period comets are the reliable ones. We know when they're coming, we know where they'll be. Predictable here just means the countdown is real. So what happens to the comets that never learn to keep a schedule at all? Long-period comets come from somewhere so far out, we barely count it as part of the solar system. That's their home, the Oort cloud, a shell of icy bodies surrounding the sun so distant that sunlight takes over a year just to cross it. Their orbits get stretched so thin they're barely ellipses anymore, more like a needle with the sun pinned at one tip. Something as small as a passing star's gravity can knock one loose, and it starts falling, a trip that can take millions of years to finish. Comet Hale-Bopp made that fall in 1997 and stayed visible to the naked eye for over a year before heading back into the dark. Astronomers even have a name for comets like this, single apparition, because a single look is all we ever get. No warning, no repeat performance, just one pass across our sky forever. A close pass by a planet can bend their path just enough to fling them out of the solar system entirely. No second trip, ever. These comets can vanish for millions of years. The next kind on this list doesn't get that luxury. It dies on the very first trip in. Take that same sunward fall and push it as far as it goes, and you get the Kreutz Sungrazers. They're not separate comets at all. They're fragments of one giant comet that broke apart centuries ago, and thousands of its pieces still fall the exact same path. That parent comet must have been enormous. Its shattered pieces are still raining into the sun, centuries after the breakup. A sun-watching spacecraft named Soho has now caught over 4,000 of these fragments diving in and counting. Most don't survive. They pass within a few solar radii of the surface, and the sun simply tears them apart. The Great Comet of 1843 is the ancestor of them all. It swung so close to the sun it was visible in broad daylight. For a few hours, some of these become the brightest thing in the sky besides the sun and moon, right before they're gone for good. In 2011, Comet Lovejoy dove straight through the sun's outer atmosphere and, against every expectation, came out the other side, tail intact. Remember the question we opened with, which ones make it out alive? With Sungrazers, the odds finally get brutal. Here's what every comet on this list does the moment sunlight actually reaches it. It grows two separate tails, not one. The icy nucleus alone is too small and dark to ever see from Earth. Everything you're actually looking at is sunlight bouncing off gas and dust around it. The dust tail is exactly what it sounds like, grit and ice shaken loose by sunlight, curving gently behind the comet like smoke. The iron tail is the violent one. Solar wind rips charged gas straight off the comet and fires it out in a dead straight line. That's why a tail never trails behind a comet like exhaust behind a car. Both tails always point away from the sun, even while the comet is leaving. None of this happens far from the sun out past Jupiter. Most comets are just inert, frozen, and tailless. Hale-Bopp's tail stretched across enough of the sky to be traced for months after it passed Earth. A comet, then, isn't really one object. It's a frozen core, and a plume of itself it's actively losing to the sun with every pass. Every trip past the sun costs a comet material it never gets back, which means every Sungrazer we just covered is dying a little more each orbit. In 2017, something flew through our solar system that didn't come from our solar system at all. Its path was hyperbolic, moving too fast for the sun's gravity to ever capture it. Proof it came from another star system and is leaving for good. Astronomers tracked it for only a few months before it faded past reach. We'll likely never see another object exactly like it. It even sped up slightly on its way out, in a way gravity alone couldn't explain. The leading guess is escaping gas too faint to detect, but nobody is fully certain. Space telescopes trained on it for every spare second they had, and it still kept most of its secret. Astronomers only tracked it for about a week before it faded past reach. We'll likely never see another object exactly like it. 2 years later, a second interstellar visitor showed up, Comet Borisov, and this one behaved exactly like a comet should, complete with a glowing tail. Spotting 2 interstellar comets within 2 years of each other means the galaxy is flinging icy debris between stars constantly, not some rare fluke. Neither object announced itself early. Both slipped through most of their approach before anyone happened to be looking in the right direction. Both are now headed back out, drifting toward another star system entirely, on journeys that will outlast every civilization that ever tracked them. Here's the part that changes how you see everything we just covered. It isn't a metaphor, it's the literal same chemistry, the same ice, the same leftover dust from the same collapsing cloud. Short period, long period, Sungrazer, tail, interstellar. Every single one is built from the exact same primordial material. All of it is leftover ice and dust from the birth of the solar system, 4.5 billion years ago, frozen solid and untouched ever since. Which means every time one of these swings past the sun and boils away, you're watching an actual piece of the cloud that built Earth evaporate on camera. So back to the question we opened with, which ones make it out alive? Let's watch the most extreme Sungrazer ever tracked answer that in real time. This is a Kreutz fragment on its final dive, passing just a few solar radii above the sun's visible surface, closer than any planet has ever been. By the time it's this close, the comet is moving at incredible speed, whipping around the sun in a matter of hours, not days. At that distance, it isn't just hot. It's inside the sun's outer atmosphere, the corona, hit with heat and radiation no ice was ever built to survive. The ice doesn't melt so much as skip straight to gas, venting outward in violent jets bright enough to catch on camera. Its surface boils away in real time, streaming off as gas and dust faster than the comet can hold onto any of it. There's no rescue, no do-over. Whatever survives the next few minutes is all that's left of it. Solar telescopes have watched comets like this get brighter and brighter as they close in, then just stop. No re-emergence on the other side, nothing left. Comet ISON did exactly that in 2013. It approached bright and promising, grazed the sun, and simply never came back out the other side. ISON had survived close calls before that. This dive was supposed to be its defining moment, and instead it was its last. A rare few Sungrazers do survive, thinned down to a fraction of their original size, dimmer and changed forever. Loveji managed it. Most don't. Most come apart mid-dive instead, spreading into a trail of dust that keeps circling the sun long after the comet itself is gone. Either way, nothing that dives this close leaves unchanged. Surviving here just means surviving smaller. So that's the honest answer to the question we opened with. Most Sungrazers don't make it out. The sun is not a place anything visits twice. These aren't just pretty streaks across a night sky. They're 4-billion-year-old time capsules, and some of them are dying on camera for us to watch. Some of the meteor showers you've wished on were literally comet dust, shed centuries ago, burning up in the atmosphere above you right now. Next time you spot one, you're not just seeing ice and light, You're watching the raw leftovers of everything in this solar system, including you. If a comet skimming the sun sounds extreme, wait until you see what happens to a star that falls into a black hole. That's next. Subscribe to Cosmic Scale. The solar system has been trying to destroy itself in interesting ways for 4 billion years, and we're not done cataloging it.